Hello, and welcome to Ask Swagelok. I'm Beth Neeser, and I'm here today at the Swagelok Hose Building with Margaret Brennan and Doug Nordstrom, who are our hose experts for the semiconductor space. And today we're really here to talk about the importance of properly routing hose in a semi-fab. So Margaret and Doug, can you just start by talking about proper hose routing? Why is that so critical?
Routing is extremely critical for hose applications. I'll focus on the application that connects support equipment down in the subfab to tools up in the clean room. We've seen fabs transition to flex lines in these applications just because it saves so much time and labor during maintenance and tool installation. Routing specifically is important because it affects the performance and the life cycle of the hose. So things like overbending to get through tight spaces, that can kink a hose and affect its performance. Same with bending too soon at an end connection, it can sever the layers and affect the performance of the hose. And then also, if you have extreme temperatures running through the hose, that can affect the spatial needs or surfaces that come in contact with hoses as well.
Okay.
And we need to keep in mind also with these applications in a clean room and in a subfab, space is really at a premium, so it's very difficult to find the right routing for these hoses and avoid the problems that Margaret had mentioned.
Okay. So you mentioned that spacing is important. Why is that?
Yeah, so spacing is really important, especially when it comes to the extreme temperature applications. In a fab, you'll typically have extremely cold water that can run through these hoses, and when they're in contact with each other or with other surfaces, cold spots can form. The same goes for the hot side. So when you have extremely hot temperatures running through these hoses, you can have hot spots forming in between. With the cold applications specifically in subfabs, that can cause condensation and icing to form, which leads to downtime and performance issues. So customers really like to avoid that.
Okay.
And again, in a subfab, there's not a lot of space, so these hoses get routed up against each other, causing these problems quite often. So we've worked with some of these customers on creating an actual physical spacer so they cannot actually touch each other and create the cold spots or hot spots. So we've been able to work with them on something as simple as this. We can put this between the hoses, and now the hoses can't be routed too closely together, and it avoids those hot spots and cold spots.
Okay. So when is it okay to bend a hose and when shouldn't you?
Yeah, okay, so Margaret mentioned the difficulties in routing. Of course, every hose is intended to be bent so it's routed from one spot to another. The issue with bending a hose, though, is not to surpass the minimum bend radius. So every hose has a minimum bend radius, which is the point where it no longer is elastically deforming as you bend it, it now plastically deforms, and that now represents a damaged hose. This hose will no longer perform the way it's intended to, will no longer contain the same amount of pressure. So it's important to keep in mind that you don't bend a hose past its elastic limit or its minimum bend radius. When we take that same hose and we put insulation on it, it doesn't actually change the minimum bend radius. It's not going to be damaged any sooner because of bending. So the minimum bend radius of this hose is the same as before it's wrapped with insulation. However, as you bend that, you can see the insulation on the outside of the bend is stretched, and on the inside of the bend, it's compressed. And this stretching and compressing changes the performance of the insulation, so it won't perform as well with the insulation aspect of it. Now, that means we try to maintain 3 times the minimum bend radius of an insulated hose as a non-insulated hose. So if this hose, for example, has 2-inch minimum bend radius, we would want to maintain about a 6-inch minimum bend radius on an insulated hose.
So when is hose insulation necessary?
Yeah, so taking a step back in a fab, a lot of processes require different heating or cooling at the tool. So this temperature regulating fluid is provided from chillers or heat exchangers or other support equipment in the subfab. Well, when the media needs to transport all the way up to the tool, a lot of heating and cooling can get lost along the way. So that's where insulation comes into play depending on the temperature that's running through the hoses.
And it's important to keep in mind, Margaret mentioned this earlier, that if the outside temperature of a hose goes below the dew point, it can start to form condensation, similar to an ice glass in summer. You get condensation out of the air forming on that hose. Now that's only water, but in a subfab, they don't really know what that liquid is, so they need to shut down the process to make sure they understand what that liquid is, and this now costs a lot of money for shutdown time. So they started using insulated hoses to avoid going below the dew point, and we can wrap more and more layers of insulation on here so that it stays above the dew point. But this physical insulation material is only good to about minus 30 degrees C. So as temperatures go lower and lower for these processes, we need to find a different insulation technology, and that's where this hose comes into play. This is a vacuum layered hose. So on the outside of the inner hose, there's a vacuum layer, and this eliminates any convection heat transfer and provides proper insulation down to cryogenic temperatures like -200°C. So this is really the wave of the future.
Great. Thank you for all that information, and thank you for joining us for Ask Swagelok.